Hello, everyone. This is a short video on taking limits at infinity. Limits at infinity, either plus infinity or negative infinity, with some exponential type things. We already see the solutions are 0 and infinity. This problem comes from our Canvas page and under, let's see, proficiency assessment study guide, scroll down and you'll find old exams. This is specifically under review problems and the questions for L1, L2, since our assessment is tomorrow for L1, L2. Okay, so let's work through these. Number one, let's take a limit as x goes to infinity, and I'm going to write the 10x to the negative 2 as 10 over x squared, and then e to the negative x as 1 over e to the x. And then what we do not want to do, it would be incorrect to say this is 10 over infinity squared plus 1 over e to the infinity. You do not want to evaluate at infinity because infinity is not a value. So let's take that back. Instead, let's look at each term. So we're wondering what the limit of this term will be and the limit of this term, and you can analyze this individually. So just focus on the 10 over x squared. The numerator 10, that's the limit of the numerator. It's going to 10. Denominator, x squared, that limits to infinity as x gets big. So to indicate that, let's take x squared. That goes to infinity, and then you could even circle or box in the whole fraction. That whole fraction goes to 0 then. Anytime you have a fixed number over a denominator getting big of whether it's positive or negative, it goes to 0. And then similar idea on the next term, 1 over e to the x. Denominator gets big. The entire fraction goes to 0. So we have 0 plus 0. This is 0. Then number 2. Number 2, what's different is that we're taking the limit, and as it gets big, it's negative big. So let's keep 10 over x squared, but then the e to the negative x, let's leave it e to the negative x without rewriting it as a positive exponent. All right, so this x is going to negative infinity, but then because of the even exponent, denominator goes to positive infinity. It's as though you're taking a negative really big value, you're squaring it, which makes it a really big positive value. Then we're looking at all of this. That's 10, a fixed number, over a big denominator that's positive. This goes to 0. Then, and I should say, even if the denominator were negative, let's say, just for example, let's say the exponent wasn't there, and we had 10 over x as x goes to negative infinity. This is still going to 0, whether the x is positive or negative. All right, then the last e to the negative x. This is negative, or the x will say, goes to negative infinity. But then we have the negative of that. So all of this exponent goes to positive infinity, and we have e to positive infinity just keeps getting bigger. So we have the 0 as the limit for our first term, infinity as the limit for our second term. That's 0 plus infinity, and we get infinity. Okay, so now then it's asking you one last question. It's asking you, does the graph have any horizontal asymptotes? To answer that question, you need two limits, a limit going to positive infinity and negative, and you're looking to see if either limit at infinity is a value, and this one is. So y equals 0 is a horizontal asymptote, and it's the only one. So it's the horizontal asymptote. The only way to find another one would be to look at the limit going to negative infinity, but we didn't get a value. So there's no horizontal asymptote as x gets negative big. So, and I'll write that out. Since the limit as x went to negative infinity, 10 over x squared plus e to the negative x was infinite, not a value. There's no horizontal asymptote as x approaches negative infinity. All right, hope that's helpful. Y'all take care, and please reach out if you need to, and good luck tomorrow.